All right. We are going to talk today about bonding. We're going to talk about bond diagrams. Not pond diagrams, but bond diagrams. There we go. My pen is working now. You will see some folks who call these Lewis diagrams. Some folks call these Lewis structures. I don't like calling them that because it confuses people with Lewis dot stuff that we were drawing yesterday. And they're related, don't get me wrong, but I like to call these bond diagrams just because that's what they are to me. We're going to be drawing bonds. And the bonds we're going to be drawing are covalent bonds. Covalent bonds, we've already kind of talked about this. Covalent compounds are sharing electrons. So covalent bond is two or more electrons shared between two atoms. And here I put shared in quotation marks because the only things that can share are things with a brain, and atoms don't have brains. So what we've got, what we imagine here is we remember way back when we first started talking about chlorine, which is maybe this is the first time we've talked about chlorine, but we do the electron configuration of chlorine, and we see that chlorine has neon, and it's got 3s2, right? And we got 3s2, and we had 3p5. You can confirm for yourself that that's the electron configuration for chlorine. And then we took this and we drew it. We did orbital filling diagrams for this thing. And what we see is that a chlorine atom has an orbital filling diagram that looks like this. And whenever we draw the Lewis dot structure for a chlorine, it looks like this. And remember, we put the S on the left, and then we put the P on the other three sides. So this is what this looks like right here. What we see is there is a hole in the chlorine right there, and there's a hole on this side. And so there's a hole in this chlorine. And what we see in nature is that chlorine wants to fill that hole. It wants to put an electron in that empty spot. And that, for some reason, and the reasoning for that involves a lot of calculus and a lot of quantum mechanics. We're not going to get into that. But for some reason, chlorine goes out and it seeks an electron to put into that place because it makes it more stable. Now, you hear a lot of people talk about how it makes it happy, how this makes it less likely to react, how it makes it look like a group 18 element. All of these are different explanations for what's going on here. And it just is that chlorine has an extra slot there, and it wants to put an electron in that slot. So the classic example to look at here is what happens when you take a chlorine atom that looks like this, and I'm going to draw another chlorine atom that is a mirror image of that chlorine atom. So we got a chlorine and a mirrored chlorine. So what's going to happen here, right? You'd like to imagine there's a hole right here on this side. There's a dot missing on this side of this chlorine. And there's a dot missing on this side of this chlorine. So in theory, right, we could move this atom, this electron over, and that would give me 8 around this atom. But now this chlorine atom's missing some. So maybe it goes the other way around. Maybe this electron comes in here, and you're like, well, but now if I remove this electron, now this chlorine atom's going to be missing some. This one's going to be at full octet. So how do we solve this problem? Full 8, I should say. How do we solve this problem? Well, what we do is instead of saying that they give electrons to each other, what they're going to do is this one's going to share its electron, and this one's going to share its electron. And what we're going to see then is they are going to form a covalent bond. And I draw my covalent bonds like this, okay? There's a single line between the two. And that is a covalent bond, right? And that is how we draw it. A line represents a covalent bond. They are sharing 2 electrons. All right, that's how I want you to know it. That's how I want you to see it drawn. Now, I'm not going to draw all the extra dots around these, But if you're looking online and you see some folks don't like to draw it as a bond, they'll just put 2 dots between the 2 chlorines. But I don't like that because to me that doesn't show that they are sharing those 2 electrons, right? This is just like those 2 dots are just sitting there. They haven't formed anything new. I also don't, I'm not a big fan of some folks who draw it, will draw it like a barbell. It's kind of meant to show that there are 2 electrons in there. I don't like to draw that. 1, it involves more work, but 2, it's just kind of weird. The usual accepted procedure for drawing this is to draw it just like that, where there's a line in between those 2 and shows that they are sharing 2 electrons between them.